In this video, we are going to prove the following lemma. Let A, B, C, and D be objects, and suppose that the pair set of A and B is equal to the pair set of C and D. If A is equal to C, then B is equal to D. Okay, now, before we get into the proof, what do we mean by pair set? Well, this is what we mean. Given any two objects, x and y, we say that the pair set of x and y satisfies the following statement. Given any two objects, x and y, the pair set of x and y satisfies for all objects t. T is an element of the pair set of x and y if and only if either t is equal to x or t is equal to y. Okay, so now let's get into proving this lemma. And to start out our proof, let's give ourselves four objects, A, B, C, and D. And let's suppose that the pair set of A and B is equal to the pair set of C and D. And our goal is to prove if this is true, then this is true. So let's assume that A is equal to C. Our goal is to prove that B is equal to D. And to start, we know that B is an element of the pair set of A and B. Why? What is the pair set of A and B? Well, if we take x and y and substitute them for A and B, well, the pair set of A and B satisfies the statement that for all objects t, t is an element of the pair set of A and B if and only if either t is equal to A or t is equal to B. Well, B is equal to B, so either B is equal to A or B is equal to B. Therefore, B is an element of the pair set of A and B, which is why we're allowed to say this. Right? Kind of obvious, but that's justified by what we have up here. Well, since B is an element of the pair set of A and B, and the pair set of A and B is equal to the pair set of C and D, B must be an element of the pair set of C and D. But what does it mean for B to be an element of the pair set of C and D? Well, if we substitute x for C and y for D, we get that for all objects t, t is an element of the pair set of C and D, if and only if either t is equal to C or t is equal to D. Well, in this case, we have that B is an element of the pair set of C and D. So, either B is equal to C or B is equal to D. Right. So, either this or this is true. And so what we're going to do is we're going to prove in either case we have that B is equal to D. Let's start with this case where B is equal to D. Now in the case where B is equal to D, we have precisely what we want to prove, so we're done. Now let's look at case 2 where B is equal to C. And now we're going to divide this case up into two other cases. And the way we're going to do that is by observing that D is an element of the pair set of C and D. Right? For the same reason that B is an element of the pair set of A and B, we have that D is an element of the pair set of C and D. And since the pair set of A and B is equal to the pair set of C and D, this means that D must then be an element of the pair set of A and B. And what this means is that either D is equal to A or D is equal to B. And so what we're going to do is we're going to consider both cases. And in either case, we're going to prove that B is equal to D. And let's start with this case where D is equal to B. Well, in this case, B is equal to D, so there's nothing more to prove. Now let's move on to the other case where D is equal to A. Well, in the case where D is equal to A, we can show that B is equal to D through a chain of equalities. We know that we are working under the condition that B is equal to C. And we are working under the assumption that A is equal to C, and we are also working under the assumption that A is equal to D. So B is equal to D. And that's exactly what we wanted to prove, so we're done. So what do we see here? Well, in either one of these two cases, we have that B is equal to D. So, in case 2, we have that B is equal to D. And now we see that whether or not we have case 1 or case 2, we have that B is equal to D. So, from the point at which we have either B is equal to C or B is equal to D, well, one of these two cases happen, and we have that B is equal to D. So what do we see here? Well, from our assumption that A is equal to C, we ended up deducing that B must then be equal to D. Therefore, if A is equal to C, then B is equal to D, and that's exactly what we wanted to prove. So this completes the proof. Now, as you may have guessed, the converse is also true. That is, if B is equal to D, then A is equal to C. In addition, if A is equal to D, then B is equal to C. If B is equal to C, then A is equal to D. But you know what? I'll leave proving those as an exercise for the audience, right? That was good. It's like, oh, I gotta prove them now, okay. And yeah, those other three results are really just corollaries of this lemma and the fact that for any two objects A and B, the pair set of A and B is equal to the pair set of B and A. But yeah. Anyways, yeah, that's pretty much it for this video.